Hey guys! So, today we're going to answer a subscriber question, or at least talk a little bit about a great point. So let's get into it. So the question in question was basically, Frederick, how, if it is possible at all, how can we write software, or how can we account for changes in features and requirements? So let's see if we can talk about that for a moment. You see, that's all but impossible, almost. Well, it's not impossible, but it's really hard. Yes, because the thing is, guys, when it comes to software, the one constant, at least what I've found, is that software always changes. It always changes. It doesn't matter how sure you are, it's going to change. And that's actually wherein the complexity of software development lies, because nothing is hard if you just build it as a single unit and ship it as that single unit, because that way you can for the most part just test everything once, be certain that it works, ship it, and never think about it again. This is actually one of the biggest mental mistakes a lot of, let's just call them inexperienced stakeholders have when it comes to software development, because it's a very different sort of beast. I like to make the analogy to a car. It's very easy, quote unquote now, it's easy to build a car, because whenever you want to build a car, you build it from the parts that you have available, you ship it, and that's the end of the story. And if you want to build another car, or if you want to attract more customers, you start from scratch again. You take the learnings you've had, build it from nothing again, and ship it again. But it's still the same car. Well, it's a very similar car to the one you've already built. But what if you always had to have the exact same car, and the only thing you were able to do was not to ship something new, you had to update the thing that you already have and change it and add requirements and all of that good stuff. That's what software development is about. You don't ship new things, you change the already existing thing. And when it's a small system, that's not a big problem, but when it's a big system, it becomes a really big problem. And that's why we have seniors. Yes, guys, that is the answer to this question. Well, it's a two-part answer to this question. First and foremost, if you want to be able to have a way of predicting what likely features and the sort of considerations you need to make when you're writing software, you need experience. This is one of the things where I've said quite a few times to the juniors out there, you will get design patterns wrong. Because design patterns, guys, this is something that ties into exactly that. Knowing when to use a design pattern is one of the things that you learn when you want to answer this sort of question. In essence, how do you write software that can account for changing requirements? In order for you to even answer that, you already have to know what the most likely next requirements are, or how to write software in such a fashion that the likely changes that are going to come your way are easy to account for. But at the same time, you also have to think about not over-engineering things, which is something that most juniors can't either. And as I said, it's just the way it is, guys. You just have to work until you start figuring these sorts of things out. I mean, I was there as well. I've been on both sides of spectrums, where I have had no foresight, and also when I thought I had foresight, but I just ended up writing a really shitty, complicated implementation because something may happen in the future. So this is why, and a few of my coding videos, I've actually had this as a part of the senior test, and I still stand by this today as well, where I claim that how to determine whether or not somebody's a senior, the easiest way to do that is to just present them with this sort of challenge. Just show them a challenge that you know is going to be one of the harder things to get right in the field that they for the job that they are applying for. In this scenario, it was front end, and in front end, among the hardest things that you can build are CSS frameworks, translation solutions, component libraries, good architecture, that sort of thing. And I mean, it doesn't matter I've had tons of juniors who say, oh, I already know this, I know that, and I know this, and I kind of go, yeah, maybe you do. Odds are that you don't, because and that's kind of the mental mistake here, just because you can solve it doesn't mean that you can solve it well. That's the tricky part about this. It's easy to implement a bad theming strategy, for example. That's super easy. Anybody can do that. But if you're supposed to prove that you're a senior, then your solution should be scalable and it should be sustainable over time. And that's something you can't fake. A junior cannot fake this at all. It's not possible, because the only way for you to learn how to do this is to actually do it and make the mistakes. So that's number one, guys. You have to have experience to be able to foresee what the most likely features are. You have to have an intimate knowledge of the domain that you are working within, so that you can understand that, all right, these are the areas that are most likely to be updated quite a bit. And when you can answer that question, when you have that experience, then you can start thinking about the next part, which I think is equally important, and that is to write what I call disposable code. Some people like to call it loose coupling, but in my experience, people who talk about loose coupling also seem to, in the same breath, think that that means that you have a lot of interfaces and that you use dependency injection and things of that nature. And that's not really loose coupling to me. Or rather, it is loose coupling, but it's not the same thing. Because at the same time, when I talk about loose coupling, I want to stress that it's equally important to keep down the complexity. And sometimes I think that people go a little bit too far, especially with dependency injection, where they complicate things even further than they need to. And to me, disposable code is the sort of code that will be very easy to throw away if needed. Now, this is the insight that I came to the hard way, I would say, after spending quite a few years trying out all the best practices that were sold to me from all different kinds of angles. A good example of a disposable approach to a problem is to use something like C# or Java's domain-driven design approach, where you have services that perform different tasks and so forth. Now, I'm not saying that this is the best way to write software, but it is the most disposable way I have found to be able to write software. And what I mean by that is that if you have a suite of different services that all are representing one part of your domain, and they have a very specific piece of functionality that's associated with them, and they simply respond to different requests that is coming from the network or from the client, it's very easy for you to add functionality to those services, and it's also very easy for you to throw those services away, or throw away a method on a service that executes a certain task when it's no longer needed. That is a there are tons of limitations, guys. This is not in any way the perfect way to write software, but it is very disposable. It scales extremely well, and it's very easy to comprehend for quite a lot of people. And it's why I will argue it's one of the most popular ways of structuring enterprise applications. That's just one example of how to write disposable code. I mean, you can do it in a functional manner as well. If you heavily leverage composition, you can switch out functions and all that good stuff as well, and keep everything as a pure isolated function. In my experience, it gets a little bit more complicated doing things that way, at least for comprehension. But that's basic. That's virtually it, guys. So to summarize, in order for you to be able to predict the sort of considerations or to account for changes in specification, number one is that you need to have the years. You need to have experience. It cannot be done by somebody who is a complete beginner, because odds are that you don't actually understand your stakeholders and the sort of considerations that the company needs to make, or what's most likely going to happen to the company. Second thing is, you need to know how to write disposable code. The sort of code where, it doesn't matter how fancy your implementation is if it cannot be easily thrown away. It's more important that you have code that is easy to maintain and easy to change than it is that you have clever code. Clever code is bullshit, guys. Clever code is just legacy waiting for the most part. Because as I said, the one constant is code always changes, and unless you are always the person who's going to read your code, maintain your code, and doing all that stuff on a fairly regular basis, because 6 months from now you may not even remember what your code is doing, and if you then put yourself in this really bad situation where you can't just throw that away, you're kind of stuck with it. And that's how legacy gets born. Have a great day.